Hello, MMW students. This will be our last lesson for our pre-finals, which is the chi-square. Ayan, sabi ko nga nung past discussion natin, magagamit ninyo ito sa research ninyo pagdating ninyo ng third year. Kaya hindi pwedeng hindi natin siya ma-discuss. Nung grade 12, siguro na-discuss niyo about t-test, ANOVA, yan. Continuation niya lang ito about statistical test na pwede nating maggamitin sa mga research. So what is chi-square? The chi-square test is used to determine whether there are significant difference between expected frequencies and the observed frequencies in one or more categories. Yan. So ano ba itong expected frequencies at observed frequencies? So, malaman natin yan dito sa formula. So we have two types. Focus tayo sa goodness of fit and test of independence. So to calculate the chi-square, so yan yung x squared natin, the Greek letter x, use the following formula. So chi squared is equal to the summation of observed frequency minus expected frequency squared all over the expected frequency. So wherein x squared ay tinatawag nating chi-square test and observed frequency or O, ito yung mga nakuha nating data from our actual experiment. Tandaan nyo po yun ha, observed frequency ay yung mga data na nakuha natin from actual experiment. While E is the expected frequency value for the event. So ano naman itong expected frequency? Ito naman yung basis natin kung saan natin kino-compare yung nakuha nating data. Para mas maintindihan natin, focus tayo dito muna sa ating goodness of fit kung paano siya ginagawa. Pero bago natin simulan to, kailangan muna natin alam kung saan ba ginagamit itong goodness of fit. So check muna tayo sa assumptions. Ano ba yung mga assumptions natin? Number one categorical variable. It can be nominal or ordinal. So iisa lang yung ating variable. Number two, independence of observation. It means that there is no relationship between any of the two cases. So, independence, so there is no relationship between the two categories or cases. Next, the group must be mutually exclusive. Ibig sabihin, one response lang per category. And number four, at least 5 expected frequencies in each group of your categorical variable. Ayan, 5 expected frequencies tayo. Kasi at least 5 para makikita natin yung accuracy ng test natin. Okay, try natin mag-solve ng isang problem dito sa goodness of fit. Ayan. So ano ba yung process? Balikan natin saglit. Ayan, nakalimutan ko yung ito. Okay. Ayan. So step 1, observe frequencies are calculated for the sample. Step 2, the expected frequencies are obtained from previous knowledge or belief or probability theory. Ito na yung gagawan tayo ng hypothesis test. So letter A, the null hypothesis. Ang symbol natin dyan is H sub O. Ang tawag natin dyan ay null hypothesis. The population frequencies are equal to the expected frequencies. Or the observed frequencies are equal to the expected frequencies. Yun yung ating null hypothesis. While on the other hand, we have H sub A, the alternative hypothesis. The null hypothesis is false. Ayan. Siyempre. Kaya nga tinatawag natin siyang alternative hypothesis. Ninenegate niya yung ating null hypothesis. And letter C, check the level of significance. yung alpha na symbol. And the degrees of freedom, we have the formula K minus 1. O, saan natin to ginagamit? So, pansinin ninyo, meron tayong ganito sa module 2 ninyo sa ELMS. Yan yung tinatawag nating chi-square distribution table. Yung nasa upper part natin, ito yung tinatawag nating level of significance. Yan. Yung mga rows natin. We have 0.01, 0.025, 0.05, and so on. Yan. Given naman yan, binibigay yan dun sa ating nagiging problems. Then, we have D.F dito, yung tinatawag nating degrees of freedom. Yan. K minus 1. A test statistic is calculated for letter E. Test na natin gamit yung formula. Then F, from the alpha and degrees of freedom, a critical values is determined from the chi-square table. Ito na. Gagamitin na natin yung table natin. And magko-conclude na tayo. Reject the null hypothesis if our chi-square test is larger than the critical value. O kapag mas malaki yung na-compute nating chi-square test compared dito sa ating nasa table na critical value. And ito yung tinatawag na right tail test. Okay. Para mas maintindihan, solve tayo ng isang problem. Researchers have conducted a survey of 1,600 coffee drinkers, asking how much coffee they drink in order to confirm previous studies. Previous studies have indicated that 72% of Americans drink coffee. Below are the results of previous studies. So ito yung previous studies, nasa left, and the survey yung nasa right. Ayan, ito yung survey natin. At alpha level is equal to 0.05. Is there enough evidence to conclude that the distributions are the same? Okay, so check na natin ngayon. So tandaan, may formula tayo. Gagamitin natin yung formula. Ating formula ay summation x chi squared is equal to yan, balikan lang natin yung formula. Ito yung formula natin. The chi squared is equal to the summation of observed frequency minus expected frequency raised to 2 divided by E. So, balik tayo dun sa given. Ito siya. Next, so, gawin na natin yung step by step. The null hypothesis. So, kunin lang natin yung ating nasa pattern na the observed frequencies are equal to the expected frequency. Saan galing yun? So, dito sa process ng null hypothesis natin. The observed frequencies are equal to the expected frequency. Next, null hypothesis. So, ganun lang din. Kopyahin lang din natin yung null hypothesis natin. Negate natin yung alternative hypothesis natin. We're just going to negate the null hypothesis. So, the null hypothesis is false. And level of significance, ito siya, 0.05. And the degree of freedom, we have the K minus 1. So, yung number of column natin, column na yun, 1, 2, 3, 4. That's why we have 4 here. 4 minus 1 is equal to 3. Okay. So, next step tayo. Since kailangan natin yung ating observed frequency and expected frequency, so i-compute natin ngayon. So, kita nyo yung table. Ito yung nasa given kanina. Response, 2 cups per week, 1 cup per week. So, meron tayong percentage dito. Now, kunin natin yung ating expected frequency. Paano? So, Dito sa 2 cups, pansinin natin na may 15%. So, i-multiply lang natin dun sa ating population. Ang population natin, according sa our given, is 1,600. Kaya notice ninyo, meron tayo ditong 0.15. Saan galing si 0.15? Yan yung decimal equivalent ng 15%. So, to get the 15% of 1,600, we need to multiply 0.15 times 1,600. Kaya nakuha natin si 240. Same process, 13% or 0.13 times 1/6, that is 208. Then 27, that is 0.27 times 1,600, so 432. And 45%, 0.45 times 1,600 is equal to 720. So, meron na tayong expected frequency. Now, according to our formula, O minus E. O, saan natin makukuha si O? Sabi natin kanina, ang ating observed frequency, ito yung mga nakuha nating actual data from our experiment. So, ito yon yung frequency natin dito. So, ilalas lang natin, mangyayari, 206 minus 240, we have negative 34. Next, observe natin dito is 193 minus 208. That's why we have negative 15. Next, 462 minus 432 is 30. And last, 739 minus 720, we have 19. Then, square lang natin, negative 34 raised to 2, that is 1156. Negative 15 raised to 2, that is 225. Then 30 raised to 2, that is 900. Then 19 raised to 2, 361. At since meron na tayo nito, i-divide lang natin siya sa ating E. Sa ating E, ano ba yung E natin? Ito yung mga E natin. Yung mga nandito. So, mas maganda na meron kayong calculator dyan para ma-check ninyo na 4.82 nga yung lalabas kapag dinivide natin ng 1,156 divided by 240. In decimal, 4.82. Tama? Next, 225. 225 divided by 208. That is 1.08. Okay, 1.08. Next, 900 divided by 432. We have 2.08. Ayan. And last, 361. 361 divided by 720, we have 0.51. Now, summation tayo. So, we need to add lahat na nandito. And that will give us 8.47. Okay? Pwede nyo i-check gamit ang calculator ninyo. Next, kapag nakuha na natin yan, ite-test na natin ngayon. Yan. So, 8.48 yung nakuha natin. So, gamit yung ating level of significance, the alpha is equal to 0.05. And the degree of freedoms, that is 4 minus 1, kaya meron 3. Gamitin natin yung ating chi-square distribution table. So, 0.05 at saka 3, pagtatamain lang natin. So, we have 7.81. Kaya yun ang nakikita nyo dito. So, ayan siya. Ayan. Kinap ko dito, nilagay ko dyan. Imimit lang natin sila dyan. Saan sila mag-meet? 0.05 tsaka 3. Okay? At ayun na nga yung ating critical value. And according sa ating steps, para mag-conclude, if the chi-squared or the computed chi-square is larger than the critical value, then we need to reject our null hypothesis. Mas malaki yung computed o mas malaki yung chi-squared natin compare sa ating critical value. So there is enough statistical evidence to reject the null hypothesis. Ayun siya. So nakuha nyo kung paano nagagamitin yung ating chi-square distribution table, yung ating formula. Ayan. So soon, sana magamit nyo ito sa inyong research. Next naman natin yung next type, which is the test of independence. Okay, proceed na tayo sa ating test for independence. So the procedure for the hypothesis test is essentially the same. So almost the same lang siya dun sa ating goodness of fit. So the difference are the null hypothesis is that the two variables are independent. So yun din pala yung pagkaiba nila. Kanina sa chi-square, meron lang tayong one categorical variable. In this test for independence, meron na tayong two variables na kino-compare. So we have the null hypothesis. The two variables are independent. Pag sinabi natin independent, there is no relationship between the two variables. And letter B, alternative hypothesis, the two variables are dependent. Ibig sabihin, may relationship dun sa variables natin. Ayan, not independent or dependent. Parehas lang yun. Letter C, step natin. So for the frequency, expected frequency, we have expected frequency R, comma C is equal to sum of row times sum of column divided by the sample size. And the degree of freedom, we have the number of rows minus 1 times the number of columns minus 1. So unlike kay goodness of fit, meron lang tayong K minus 1 dito, meron tayong rows and column. So almost parehas lang. Para mas malaman ninyo kung paano siya i-apply si test for independence, meron tayong example number 1. The results of a random sample of children with pain from musculoskeletal injuries treated with acetaminophen, ibuprofen, and codeine are shown in the table. At level of significance is equal to 0.10. Is there enough evidence to conclude that the treatment and result are independent? So, pag-aralin muna natin yung ating table. We have our rows, significant improvement, slight improvement. And for the column, acetaminophen, ibuprofen, and codeine. So, i-check naman natin yung ating frequencies. 58, 81, 61, a total of 200. 42, 19, 39, a total of 100. Paano naman sa column? 58 plus 42, 100. 81 plus 19, 100. And 61 plus 39, 100. So, dapat magtali total of 300. Ayan. So, apply natin using the process or the steps. Letter A, the null hypothesis or H sub O. The treatment and result are independent. And of course, the alternative hypothesis, the treatment and the result are dependent. Okay. Now, level of significance, given kanina sa problem. So, 0.10. And degree of freedom. So, number of rows, minus 1 times the number of columns, minus 1. Ilan ba yung rows natin? So, we have 1 and 2. That's why we have 2 minus 1. And columns, 1, 2, 3. That's why we have 3 minus 1. So 2 minus 1 is 1 times 3 minus 1, 2. So we have 2. So degree of freedom natin is 2. So from that, makukuha natin yung critical value natin. Pero kunin muna natin yung ating chi-square. Okay, syempre gagamitin natin yung ating formula. Chi-square is equal to the summation of observed frequency minus expected frequency raised to 2 all over expected frequency. Now, kunin natin yung ating expected frequency. So we have row 1, column 1. So from our given dito, row 1, that is row 1, dun tayo titingin sa total. So 200, kaya mayroon tayong 200 dyan, times column 1, 100. Divided by our, so formula natin kanina is our population, 300. So 300 yung population natin dyan. So that is equal to 66.67. So pwede nating itry using our calculator, 200 times 100. So 200 times 100, that is 20,000 divided by 300. 66.67. And gayon din naman, row 1, 200 times column 2, 100. So ganun din, divided by our population, 300. Then row 1, 200 times column 3, 100. Ganun din, divided by 300. Ayan. And dito naman sa row 2, dito na tayo, 100 times 100 divided by 300. At makukuha natin yan kapag kinuha natin yung process. And sa ating O, ito yung O natin, yung mga ating observed frequencies. So 58, 81, 61, 42, 19, and 39. O minus E, ayan, nasa loob ng parenthesis natin. Subtract lang natin. So we have 58 minus 66.67. Meron tayong 58 minus 66.67, negative 8.67. Next, 81 minus 66.67, meron tayong 14.33. 61 minus 66.67, negative 5.67. 42 minus 33.33, 8.67. 19 minus 33.33, negative 14.33. And 39 minus 33.33, we have 5.67. Ayan. So yung 300 pala dito ay yung ating sample size. Ayan. Para makuha yung ating expected frequency. Or yung sample size or the population here. Then, square natin. So, negative 8.67 squared, that is 75.17. Or simply, negative 8.67 times negative 8.67. Kapag cellphone ang gamit ninyo at walang square. So, 14.33 times 14.33. Ito yun. Then, negative 5.67 times negative 5.67. Ito siya. And ayun, just continue the process. Then nandito na tayo sa ating formula divided by our frequency. Ayan, expected frequency. So 75.17 divided by 66.67. Try ko nga, double check natin. 75.17 divided by 66.67. And that is 1.127 or 1.13. So, ganun din, 205.35 divided by 66.67. 32.15 divided by 66.67. Then next, 75.17 divided by 33.33. And 205.35 divided by 33.33. And 32.15 divided by 33.33. Ayan siya. Now, get the sum since we're talking about the summation. So, pag kinuha natin yung sum niyan, 1.13 plus 3.08 plus 0.48 plus 2.26 plus 6.16 plus 0.96, a total of 14.07. Ayan na ngayon yung ating parameter value or p-value. Compare na natin ngayon sa ating critical value. So, degree of freedom is 2 and the level of significance 0.1. Critical value, saan nakuha si critical value? Dun sa ating chi-square or chi-distribution table. Ito siya. So, 0.1 or 0.10, 0.1 equivalent niya, and 2 is our degrees of freedom. Ayan siya. 4.621. Ayan, yung nakita nyo kanina. Okay, so balik lang natin konti sa ating conclusion. Is there enough evidence to reject the HO? So since chi-square is equal to 14.07, which is greater than 4.61, therefore, there is enough evidence to reject the null hypothesis. I-reject natin yung ating null hypothesis. So, ganyan lang. So, I'm hoping na magamit ninyo ito sa inyong research in the near future. Maganda din yung Slovan's formula. Kung nare-recall pa ninyo, maganda din siyang gamitin. Yan, sa mga kapag meron kayong two variables na kino-compare, maganda itong chi-square. At magiging ready kayo sa inyong magiging final defense pag nag-research na kayo. Thank you! At sana may naintindihan kayo.